So now this video discusses about what we call as the remainder theory of dividing polynomials. So what do you think is the remainder theorem? Now let's say we have actually a polynomial given as, we should have, let's say, x squared should be x cubed, and let's say minus 2x and then minus x, and the plus, let's say, should be 15, and we should have to divide by x plus 2. You know, up to this far we have only covered the actually long division method as the only way in which the remainder can be obtained, and for the polynomials. Now this is another alternative in which we can be able to find the remainder of the polynomial using what we call as the remainder theorem. So let's see and understand about the basis of the remainder theorem. So in this case, using the long division method, this can be given as, you know, we can have, let's say, x to the power 3 minus 2x squared, you know, minus x plus 15. Let's say that is the case, and divide by x plus 2. So using the long division method, we'll have x into x cubed, that is x squared, we'll have it here, and x squared times x, that is x cubed, and x squared times 2, that is 2x cubed, 2x squared, and that is minus, so have negative 4x squared, that is upon having negative 2x, negative 2x, and have to drop down x, that is negative x. Now have 2 into negative 4x, that is x squared, that is negative 4x, negative 4x times x, that is negative 4x squared, and should be negative, actually 4x times should be 2, that is negative 8x, that is in the minus. We'll have, this is 0, then we'll have negative x, negative 2, that is being given as, you know, should be 7x, and we'll have to drop down 15, we'll have that as that. So then x into 7x, that is 7 times x, that is 7x, and of course then 7 times 2, that is 14, and upon having everything, we'll have the remainder being given as 1. So for this case, the remainder is given as 1, and the quotient it is given as x squared minus 4x and plus 7, that is. So what is the actually remainder theorem? What do you think is the remainder theorem, if that is the case? So let's have to keep this, that is the remainder is given as 1. So what is the remainder theorem if this is the case? Now let's consider the divisor, which is x plus 2, to be equal to 0. If that is the case, then x is equal to, should be negative 2. And let's consider our dividend to be a function. Now in this case, since the dividend is of x, it means it is expressed in terms of the function. We can have it as f of x is equal to x cubed minus 2x squared minus x plus 15, that is. And now this x is the same as this x, and it is the same as this x, it is the same as this x, it is the same as that x. In that case, if that is the case, then we have f of negative 2 will be equal to, now have negative 2 to the power 3 minus 2, negative 2 to the power 2, negative x plus 15. So in that case, we'll have what is in negative 2 to the power 3, that is in negative 8, and have negative should be 8 as well, and that is positive 8. Actually should be negative 2 here. So in this case we have positive 2 and plus 15. So that one. So what is in negative 8 times negative? Actually negative 8, that is a negative 16. Then what is a 2 plus? That should be 15, that is positive 17. Now in this case we have it as a positive 1. So in this case f of negative 2 is equal to positive 1. So this is, you can see that positive 1, it is the same as this remainder. Now this is what we call as the remainder theorem. You know, in all cases, what it means is that if we have, let's say, if we have the function f of x, let's say, is equal to, let's say, y, and we have the divisor which is x, let's say, plus a, should be if we have the divisor x minus a. Now in this case, having x minus a, it is the same as and the x is equal to a. Now the f of actually a, it is the same as the remainder. So in this case, this is what we call as the remainder theorem. So keep that in mind. Now let us see how we can find the remainder using the remainder theorem for the following cases. In this case, let's say I have x to the power 3 and plus 5x squared, and let's say minus 6x, there should be plus 1. And when it is being divided by, you know, x minus 1, how do you think we should have this? Now first thing, we should have to express this one as a function. Hence we'll have it as f of x is equal to x to the power 3 plus 5x squared minus 6x and plus 1. And we should also have to know that x minus 1, it is the same as hence x is the same as 1. Then we'll have f of 1, that is the same as 1 to the power 3 and plus 5 of 1 to the power 2 minus 6 of 1 and plus 1. So in this case, this is the same as 1. We have it as 5, negative 6 and plus 1. 1, that is 2. And here we have negative 1. So 2 minus 1, that is 1. So in this case, the remainder f of 1 is equal to, should be 1. So which means whenever this actually a polynomial has been divided by this, the remainder is given as 1. So keep that in mind. What if we have this? Let's say if we can have something about, let's say, 3x squared should be x cubed, rather should be x cubed, and let's say plus 2x squared, and that should be plus x, and that is minus 8. So how do you think we can have this? And when it is divided by 2x and plus 1. So in this case, we should have to express the polynomial in terms of the function. We'll have x to the power 3 plus 2x squared and plus x minus 8. And the 2x plus 1 is equal to 0. So in this case, we'll have 2x is equal to negative. X will be given as, should be negative 1, rather we'll have x is equal to negative 1 divided by 2. So now we'll have what is f of negative half. So what do you think will be that? So in this case we'll have 3 times 1 over should be negative half. So that is to the power 3 and the plus 2 1 over negative half should be negative half to the power 2, and that should be, since we have here positive negative, it is the same as the negative, so have negative half and a minus 8. So care has to be greatly considered here whenever you are operating with the calculators. So in this case we have, this is the same as having 3 times we can have negative 1 to the power 3 divided by 2 to the power 3. It is the same as that. And plus, we'll have 2, negative 1 to the power 2 divided by 2 to the power 2. The minus half, minus 8, like that. And of course, let me just have to take this one away. In this case, we have it as f of negative half, being given as, what is negative 1 to the power 3? It's the same as the negative 1. So we have 3 times, we have negative 1 divided by, what is 2 to the power 3? That is 8. Like that. And the plus, what is 1 to the power 2? By the way, we should have to include the brackets whenever we'll be operating this. The brackets has to be considered there, that to avoid getting the wrong answer. So in this case, we have 2 times we have 1 over 4, and the minus half minus 8. So have it as negative 3 over 8, and the plus, 2 into 4, that is 2. We have 1 over 2. That is negative half minus 8. So these will go, since they are since they are all the same. So have negative 3 over 8 minus 8. So we should have to actually subtract these fractions. Let's use the butterfly method in this case. So in case you don't know what is the butterfly method, just have to refer to my videos and you come across all these things. So butterfly method of adding or subtracting should be the fractions. So you have negative 3, and that should be negative 64 divided by 8. That is the same as negative 67 divided by 8. So that is the f of negative half is equal to this. So this is the remainder. And what if we have this case? Let's say if we have something about, it should be this. Let's say if we can have 4x to the power 3, let's say minus 5x, and that should be plus 2, and when it is being divided by x minus 2. So how do you think you can have the remainder for this? So as you can see, the expression is incomplete. What is missing? It is the quadratic part. But since we are just using the remainder theorem, we just have to use the same. But whenever we are using the long division method, we need to include the part which is missing. But now we just have to do it in that way. So we should have to express the polynomial as the function 4x to the power 3 minus 5x plus 2. And note that x minus 2 is the same as where x is equal to 2. Then we have f of 2 like that. So try to complete that one at your own time. Now let's say we have this question. Let's say we have the function given as f of x. Let's say it is equal to x to the power 4, and let's say minus 5x to the power 3, and the same minus x square plus 5. So evaluate the following: f of, let's say 0, and we should have f of 2, we should have f of 5, we should have f of 6. So try to have those, if that is the case. And what if we have, let's say, f of, there should be x being given as, let's say 8 to the power 3 minus 2x to the power 2 plus 5x minus 1. Evaluate f of negative 1, f of negative 2, let's say f of 5. How do you think we should have that? So try to have that one. Now let's say we have the polynomial given as, that should be x to the power 3 minus 2ax square minus 5x plus 2. Let's say when actually this expression has been divided by 1, the remainder is given as, let's say, 2. What do you think is the value of a? Let's say the expression when divided by x minus 1, the remainder is given as 2. What do you think is the value of a if that is the case? So there's nothing you should have to be worrying about. Just have to use the same principle and have the knowledge on how we can have it. So remember, we have took that if we have the function, let's say, if we have the function f of x is equal to y, and let's say if we have x, let's say minus a is equal to 0. Let me have this. We have said if we have the function f of x being equal to y, and let's say if the function, let's say if we have the function, f of x is equal to y, and when it is being divided by x minus a, you need to keep in mind that having x minus 8 is the same as x minus a is equal to 0. In this case, x is equal to a. Now the remainder of this actually, the remainder of this expression when it is being divided by this one, it is given as f of a is equal to the remainder. So this is the principle that is to be used in that case. And on the case that we have, what we need to understand is that we should have to express that as a function. F of x is equal to x to the power 3 minus 2ax squared minus 5x plus 2. Like that. And I need to understand that x minus 1 is the same as 0. Then x is equal to 1. Then we should have f of should be 1 is the same as the remainder. So f of 1 is the same as the remainder, which is 2. Then what is f of 1? F of 1 is now being, f of 1 it is now being given as 1 to the power should be 3 minus 2 a times 1 to the power 2 minus 5 times 1 plus 2, which is the same as 2. Then from here you can have 1 minus 2a minus 5 plus 2, that is equal to 2. So these are right terms. We have, this is negative 5 up to negative 3 plus 1, that is negative 2 minus 2a, that is equal to 2. Now from this point to have, negative 2a is equal to 2 plus 2, of which a will be given as, there should be negative 1. So that is the value of a in that way. Now what if we have this case? Let's say if we have, this kind of a case. Let's say if we have the polynomial which is given as, let's say, ax to the power 3 minus 6b x squared minus 2. And let's say when it is being divided by x plus, let's say, 2, the remainder is given as should be 1. When divided by x minus 3, the remainder is given as, let's say, negative 1. What do you think are the value of a and also the value of b, if that is the case? Principle remains the same. We should have to express that as a function. F of x is equal to ax to the power 3 minus 6b x squared minus 2, like that. And using the first case that we have, keep in mind that x minus 2, it is the same as equal to 0. Then x is equal to negative, it should be positive 2. Then f of 2, it is the same as the remainder, which is given as 1. Then what is f of 2? We'll have it as a times 2 to the power 3 minus 6b and 2 to the power 2 minus 2, which is equal to 1. So have it as 8a minus, that is 24b minus 2, which is equal to 1. We'll have it as 8a minus 24b, that is 24b, that is 24b, that should be 4 here. 24b, which is equal to 3. Now since a and b, these are actually unknown terms, unknown variables, that is being given as the equation 1. Then using the second information, then we should have to use the second information. Principle remains the same. Where for the second information, we have x minus 3, which is the same as then x is equal to 3. Then we should have f of 3, which is the same as the remainder. What is the remainder? Negative 1. Then we'll have a 3 to the power 3 minus 6b 3 to the power 2, and there should be minus 2. And they have 27a and minus, now that is 9 times 6. What do you think is 9 times 6? So we have 9 times 6, that is 54. So we have 54b. And by the way, we should have equal to the remainder, which is negative 1. Minus 2 is equal to negative 1. So in this case, we'll have 27a minus 54b, and which is equal to, we'll have it as 1. So in this case, this is equation 2. You solve those two equations simultaneously. Now try that on. Now sometimes upon having the value of should be a as well as the b, you can be told to express the cubic function. So in this case, the cubic function for that case will be obtained. I won't just have to substitute b, actually a as well as the b here, then simplify. That will be the function of interest. So that is, what if we have, let's say, something like this. Let's say if we have the polynomial which is given as should be m x to the power 3 minus 2x squared minus, let's say, n plus 2. And when this one is being divided by, let's say, 2m, to say 2 minus x, the remainder is given as should be 0. When divided by 1 plus x, the remainder is given as should be 2. Find the value of m as well as the n. Hence, actually find the and hence express this is actually a cubic function, not in terms of m as well as the n. So how do you think we can have that? So principle remains the same, of which try to have that on. So try to see how you can make it like that. And also we have the another case as well, which says that, let me just have this. Let's say we have the another case, which says that when the function ax to the power 3 and plus 5x squared and minus bx minus 5 is divided by x plus 2 and should be x minus 1. The remainders are 5 and negative 1 respectively. Find the values of a as well as the b. So try that on. So that's how you start to understand about what they call it as the remainder theorem. And also finally, let's try to have this. What if we have, let's say, when the polynomial which is given as should be m x cubed minus 2 nx squared plus 5, let's say, q x minus 1 is divided by, let's say, x minus 1. The remainder is given as 0. When it is being divided by x, let's say, plus 2, the remainder is given as 1. and now when it is being divided by x plus, let's say, 3, the remainder is given as, let's say, 6. What is the value of m, n as the q? Now this one requires you to have the knowledge of solving the systems of equations, of which you just have to go through my video playlist to come across how we can solve the systems of equations. So keep that in mind.